Okay, Passerians, we're going to try to do question 45 from the home enjoyment because I guess solving trig equations is hard, and we need to make sure that we know how to do that. So we got to try the second derivative test. So let's take the derivative f prime of x, which is going to be negative sine of x minus 1. So we have the first derivative. Second derivative, which is just the derivative of the derivative, is going to be negative cosine of x, and that's it. So the second derivative test is saying that you need to basically just plug in, or actually, what does it say? It says you need to find the relative extrema. So the way that we'll find the relative extrema is we'll find the critical numbers from the first derivative, which is negative sine of x minus 1 equals 0. But you could easily add 1 to both sides and get this. And you probably want your sine of x to be positive. So you're just basically solving this equation, which is from the first derivative, right? We set it equal to 0. So what you need to do is think about your unit circle and where sine of x is equal to negative 1. And sine of x is 0 here and here. Sine of x is positive 1 here. It's negative 1 here. So x must equal 3 pi over 2. And since it says to 4 pi, that's basically 2 spins. So we have to go a full spin and a little bit more. That's this guy. So that would be 2 pi more than that. That's like 7 pi over 2. Sound good to you? It's about 7 pi over 2. So 7 pi over 2. So those are our critical numbers. So we'll take these critical numbers and plug them into our second derivative. So normally what we would be doing is we take a number line, right? And we'd kind of put like 3 pi over 2 here. We might plug in 0. We might plug in, we can plug in really whatever we want. We might plug in, actually it needs to be, well, I guess 0 is okay. We might plug in, I don't know, 2 pi here, I guess. And then 7 pi over 2, right? 7 pi over 2. And then we might plug in 4 pi here, right? So this is how we could do our first derivative test if we wanted. Of course, they're asking us for the second derivative test. So we're just going to take these numbers and plug them in here and see what happens. So as we have negative cosine of 3 pi over 2. What is cosine of 3 pi over 2? 0. So test fails. That's very sad. So it fails here. And I'm guessing that negative cosine of 7 pi over 2 is also going to be 0. Is that correct? So it also fails here. So it's kind of nice that we made this number line. So what we're going to do is instead we're going to plug into, I'm going to circle this in blue. This is our derivative right here. Okay, try to look through the red lines. This is our derivative right here. And we're going to plug these numbers into our derivative. So if we plug 0 in, sine of 0 is 0, minus 1, we have a negative. If we plug in 2 pi, 2 pi, sine of 2 pi is also 0. So this is also a negative. Ooh, I'm getting a little bit nervous about this. Okay, it's all right so far. And then sine of 4 pi, these are both on the interval. Did we miss a? Also negative. I don't love it. Okay. Do we know if this is the answer? There's no max or min? Ah, weird, because of the cosine of x minus x. Interesting. Yeah, it's like an awkward looking graph. Okay. It definitely sketched me out a little bit. But however, we have no max or min. No max or min. I guess we should say local. No local max or min for this one. So this graph looks odd, and it doesn't change signs in the first derivative. So that's how we do this. We plug in numbers from the unit circle to find the signs around it. And we want to be careful of our interval. Like I almost put in a number smaller than 0. I almost put in a number bigger than 4 pi, but luckily I caught myself. Okay. So that is one type of problem that we need to talk about. I think that you might have questions about number 89, but 89 is very similar to that. So I feel that 89 is sort of covered by that. Does that feel fair? Like a fair assessment? Yeah. 89 is going to be very much an extension of that problem. So what I'd like to do is just kind of get into this worksheet that I gave you. And I just want to talk a little bit about graphs and shapes of graphs and how they're kind of like the number line, just like drawn out. So what I want to do is I want to get into this, like, I guess I'll start with this handout. Why not? So handout is the one that has all the boxes on it. And we're looking at just this little piece right here. So let's do it. So basically, what we have here is all that they've done is they've drawn out what's happening. So you can see that f of x is increasing and we're concave up. You had some homework questions like this. So this would hold water and the function is going up. So here we have the second derivative is positive. This right here is saying that we're concave up. And then we have this right here. Whoops. It's kind of a little bit messed up. There we go. This is saying this. Okay. So here we have the derivative is 0. That means that we might have a relative max or min. And the reason that it's a min is because it's concave up, which is again from this. See this? Concave up, concave up, concave up. See this one right here? Concave down, concave down, concave down. And you can kind of see some patterns here. So we're looking to kind of just understand that there's a lot of information about the graph from these values. Does that make sense? So we have a possible inflection point whenever this is 0. We have a possible relative min or max wherever this is 0, wherever the derivative is 0. We try to not to say it. So the derivative, the second derivative. So if you just kind of like look at these, kind of see if we can get a little bit of this done. Let's just kind of look at it. So what do you think? Our thoughts. As we review, determine if each of these is applicable as the x values. So this is a local max. We're going from increasing to decreasing, right? This is a local min. We're going from decreasing to increasing. This is a stationary point. This is a minus derivative, 0 minus. This is a minus 0 plus. Do you see how this is sort of a number line? Doesn't this kind of look like a number line? It's just graphed out. This is plus 0 minus. This one's weird. It's like, I think this is concave up, right? And this is concave down, I would say. It's not very dramatic, but this right here is a point of inflection, right? Now, what would you say about this? This is an undefined derivative. And we have a positive derivative here and a negative derivative there. Same thing here, right? What's going on with this one? This one's pretty weird. This one has an undefined derivative here. Undefined derivative here. We have a negative slope. I would say we're concave down here and concave up here. So I'd say this is also a point of inflection. So just kind of like getting an idea of like all the information we can get from this graph. That's sort of all I wanted to talk about. So that's really that. Just a lot of cool graphs. I thought they were cool anyways. And today we got to talk about, so we're kind of hoping that this is okay, 89, but make sure you reach out if not. And what I want to talk about is this which is which. So now what we're going to do is we're going to look at these graphs and we're going to try to figure out which one is F. This one you don't have, but I'm just getting you like kind of warmed up. So this one you don't have, but you'll have the harder ones. This one is not too bad. One of these is F, one of these is F prime, one of these is F double prime. You have similar problems, but you have the more advanced ones. I just didn't want to take up 2 pages. So which one of these, if we just look at like certain things, let's just like look at like, there's a max. Here there's like a min here, there's like a min here, there's a max here. Do you see any of these maximums? Do you see any of these like lining up with zeros of another graph? Do you see any of these maximums lining up with zeros of another graph? It's kind of important to know. What do we think might be possibly a derivative of something else? You just got to pick one. And then basically you kind of move it around. You'll like, if you thought it was the original and the derivative, sometimes you have to move those down. So it's the derivative and the second derivative. I'll explain in a second. Yes, Landon?
C is the derivative of A, which is the derivative of B.
Okay, let's just start with C is the derivative of A. So you're saying that A has a max here and a 0 there. A has a 0, a max, a min here and a 0 here, right? And we could also say minus plus. We could also say plus minus. Okay, and then you're saying that this also has a 0 here, a 0 slope, and a 0 value, plus minus. Would you guys agree that where this is plus slope, this is plus value? Where this is plus slope, oh, I guess I'm drawing the wrong one. Where this is plus slope, actually maybe this is even the better way to do it, I don't know. This is plus value. See how this is above? The green line is above, and this is sloping up. Here, the green line is above, and we have a positive slope. When we have a negative slope, right, going down, we have a negative value. When we have a negative slope here, we have a negative value on this one. When we have a negative slope here, that looks like a negative, but it's not, we have a negative value. So we have basically going up stops going down, up stops going down. We have going down stops going up, going down stops going up. And then we have going up stops going down, going up stops going down. You see it? So then what we would say is, we would start by saying that, okay, I feel that A is y and C is y prime. Now, if that's the case, that means that B has to be y double prime, right? So is the relationship between C and B the same as the relationship between A and C? So where C has maxes and mins, does B have zeros? Yes or no? Where C has maxes and mins? No, I don't think so either. So what that means is that this could be, we could still be onto something, but what we have to do is we have to slide these down. Okay, this is the best way I can explain it. This actually must be y prime, and this must be y double prime. And now we need to know which one is the number one, the top function, right? So the question is, when we look at B, where B has a 0, slope, sorry, does A have a 0 value? You see these lined up like this? That's important. It's kind of actually answering Gwen's question from earlier. And so we know that B is Y. Okay. We'll try one more and then you'll practice. They get a little bit harder. I think the big one like this is harder than the ABC one on the front. But let me do one more with you and then we will let you do this. I think this one actually is easier, so I should have done this one first. Okay, let's take a stab at where we see a 0 slope and a 0 value. I see one right away, actually. I see a max here, like a 0 and a 0. A 0 slope, m equals 0, and here the y is equal to 0, right? It doesn't do it again, but maybe that's okay. So we're going up, and then we're stopping, and then we're going down. I feel pretty good about that. And then when we go, we're going down, 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 down. It looks all right. Let's talk about C. Could C, so if this is y, and this is y prime, is C y double prime? Yeah, another shift, you think, Landon? Thoughts? Or do you see a problem?
I don't think it can be because the point at which A is 0 C also has a slope of 0.
Let's see. So you're saying where A has so tell me again, where A is 0?
So where A has a slope of 0,
A has a slope of 0 here.
C also has a slope of 0.
Okay, A has a slope of 0, C also. That's okay though. We just need to know if A's slope of 0 is a 0 value of another derivative. They could both have one, but I think this is slid over. I think this is where the slope of 0 might be, potentially. Right? Yeah, I feel that this might be slid more. This isn't drawn perfectly. I feel like this could be the 0 slope of that, potentially. So let's slide them down. Do you know what I mean by slide them down? They all get moved down. So these guys are related the same way, but instead of it, I'm going to use this weird analogy. It's like the grandfather and the father and the son, okay? Right? So they're still related the same way. The connection, they're all related by being parents of each other. This must be y double prime. This must be y prime. That means that this is y question mark, right? So let's just see. So if this is in fact a 0 slope here, it's hard to tell, and you can see that it's kind of like tight here. So that's what makes it like kind of interesting. What I'm trying to say is that if you have a dramatic maximum, you're going to have a dramatic cross through. But if you have like a very like kind of like a baby max like type of thing, you're not going to have as dramatic of a cross through as normal. See what I'm saying? This is saying like very positive, and this is like plus plus plus, a lot of plus positives. This is a tiny bit positive, so this is not very far above. So the drama of it can kind of come into it a little bit. And this doesn't really cross it doesn't cross like that, you know what I mean? And if it did, it'd be a very pronounced maximum. So I think that we feel pretty good about this. We're not quite at a 0 here, and we're not quite at a 0 here. We almost want to say that this is a 0 and this is a 0, you see? We almost want to say that. And then I would say whenever this is positive, we're above the x-axis. This is positive all the way through here. We're above the x-axis on B, right? And then whenever B is going up, A is positive. It's not a positive slope, it's a positive value. So you're looking at slopes of one and y's of the other. Does that make sense? Okay, cool. I'm going to end the recording here, but you can try this first one with the 3 sets. Put a line down the middle. A, B, C is one set, and D, E, F is another. They're not on the same graph. They're just, it's a little easier, I think. I think the one on the back is the hardest one, and one of them is a fake. There's a fake in there because there's 4 graphs. So I feel this one's easier, but draw a line between A, B, C and D, E, F, okay? They're not lined up perfectly, but they're lined up pretty well. Okay, I'll see you guys in the next video. Peace.